Yeah,
Yeah.
I
So can
shared
you,
my screen. Let
yes,
me know once it visible.
yeah, yeah, able to see, but you can close. Okay, okay, yeah, 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 yeah. Minimize and next maximize that VS Code. Yes, extra EBS. You said extra EBS. Good. 10 GB, 1 GB attached. So
Huh.
you can try it 10 GB. There is a 30 GB free, guys. You can use 30 GB.
Okay.
After that, it will chargeable. So the free tier is up to 30. You can use it. So after 30 GB, it will be chargeable, guys. Okay.
Okay.
So
You told.
whenever your work done, you guys can stop or something like stop the that instances. Otherwise, will be chargeable, guys.
Mhm.
Okay. Yes, good, very good. So can you go to the instances? So first you need to show the code. How you are trying to add, how you are trying to attach create the volume and attach the volumes. In the code, VS Code. You can show it on the VS Code. Yeah, guys. So something like so you rename it something like you rename as a main.tf. This is the so must my first EC2.tf, right?
Yeah.
So you can rename as the TF file in the left side. There is a stack, right? Yes,
Okay.
stack. You can rename that my first EC2.tf to main.tf. My
Which this
first,
one, huh?
no. My first EC2.tf.
Okay.
Yeah,
Name. Okay.
rename it. Right mouse, rename main.tf. Main, main, main.tf. Yeah. Yes. So this is the main.tf file, guide. Nice. So provider equal to AWS, region equal to US East 1, access key, secret key for connecting the AWS CLI, a resource, a web 1, T2 micro, resource, EBS, AWS EBS volume. So availability zone, AWS instance, AWS underscore instance dot web 1 availability zone. Okay. So this is the creation only, right? So where you attached that a volume to the instance, you just created a volume, right?
Yes, yes. Created a album. Actually, after that, I have no time for that.
Okay.
Okay, sir.
Okay. So you can try. Very good. Very good.
Yeah, sure.
So availability zone equal to AWS underscore instance dot web dot availability zone. So what he is trying to do is so creating a EBS volume, creating a volume, creation of a volume. So he is creating with wherever the instance volume, wherever the instance is created, that availability zone need to create the a volume. So that's the reason he is giving that availability underscore zone equal to availability AWS underscore instance dot web one dot availability zone. So whatever the web one created in which availability zone is created, the volume also created on that availability zone. Size equal to 1, tag equal to extra EBS. Very good, very good, very good. So but you can attach this to the instance. So the
Sure,
next
sure.
part is so how you can attach this instance to the how you can attach this instance
Hmm.
to the volume. Okay. So how
Yeah,
you
sure.
attach this volume to the instances. Next step is so we need to attach this volume to the instances. Okay.
Yeah.
Yeah, good, very good. Yeah, this is the main.tf. Yeah, main.tf, right?
Yes.
Yeah. So yeah, you can no worries, you can share your screen. I will give you something like or you can stop your stop sharing. Yeah, stop, right?
Yes.
So 1 second. I will take that code file, open folder. Don't know beyond download. It is asking downloads. Yeah, downloads. Well, Studio, Git recordings. let me check my code. Something like Terraform. Fetch. Guys, one second. Southeast, Southeast, SCA created. So where it is placed, C not DC, Frankfurt, US East, no, FRA. Is list. Yeah, I'm sharing my screen to you guys. What is that? June. Please let me know, guys. Are you able to see my screen, right? Are you able to see my screen, guys?
Yes.
Yeah. So for example, this is the this is a stack, for example. Okay. So this tag having the main.tf, providers.tf, remote state.tf, variables.tf, oceans.tf, data.tf, dns.tf. Okay. So what is oceans.tf? So oceans.tf is nothing but, so yeah, so something like a version is our Terraform version. So which version, guys? The Terraform you are using? So you are using the Terraform which version, guys? Terraform 1.2 point something, right? So for example, so you can provide the Terraform version. So in the versions.tf, something like whatever you are using in the versions, you can provide it. Something like a Terraform required version equal to less than or equal 0.0. So required providers AWS, source AWS, a version equal something like, so cloud init, HashiCorp cloud init equal to for. So for example, so the version and providers, something like yeah. Oh, where is that? Yeah. So I'm adding, I'm pasting in the. What is that? Yeah. So that cloud in it, right? We don't need that cloud in it. We can remove that cloud in it. Yeah. So this is the versions.tf, guys. So this is the version. Version is nothing but a provider, AWS provider and Terraform. You need to provide the, so we can remove from the main, we can send the main. So main is the default. So default one, guys. You can treat it from now onwards main.tf. So main.tf is having the EC2 instances, S3 buckets, volumes, everything will be in the main.tf. So versions.tf, in the versions.tf, something like you need to provide the Terraform version and the AWS provider version. AWS provider version and Terraform version will be keep it under the required providers. Providers. So then, so providers.tf. So what are the providers? Something like a provider. So providers AWS region equal to var.aws.region. So you can provide a region. So which region? Assuming role. Something like the DNSs. Everything will be in the providers. So next, so data.tf. So we can provide the data.tf and DNS and providers variables. So whatever the variables you need to call it, we need to add it in the variable start. So something like a variables in the variables. So these are the files, guys. For example, the versions, variables, and providers, and remote state and main. So these are the default ones. Main, providers, variables, and versions, and remote.state. So remote.state, these are the files, guys. These are the default files we need to provide it. Right? Understood, guys?
What is the use of data.tf file? What is the use of that one?
Something like so you are not specifying the something like you called, right, availability zone equal to availability zones dot AWS underscore instance dot web1 dot availability zone. The same way. So we are calling whatever, something like whatever it is. Something like here you see something like AWS internal subnets, tags, tag names. So something like a data.tf. I will show you one thing. Yeah, you see something like it is calling AWS subnet, public subnet, AGID. So it is calling in the data.tf. So whenever data something like it will be calling to the data.tf. In the data.tf, then subnets will be defined. Okay, DNS. So DNS will be defined. So something like in the main DNS dot here DNS dot. So the DNS will be added in this and this DNS. So you can remove, you can ignore it. So what are the files is main.tf, provider.tf, remote state.tf, variable.tf, version.tf. So these files must be, these files must, guys. These files must.
My understanding is yeah, in the main file now. So we require the data or like others DNS TF file that attributes or something. Then we can use it, right?
Yes. So provider. So in the providers, you can provide the providers. What are the providers? So versions, we need to keep the version of the file, Terraform, AWS. So provider, which provider you need to take it, something like provider.tf, and the versions are variables, variables.tf, versions.tf. So something like providers.tf, like main.tf. So these are the default structure for the Terraform. So main, providers, versions, and variables. In the variables, we can call it the variables. So whatever the variables in the main, something like a var dot AWS underscore instance dot EC2 or something like that. So it will be calling it, the var will be calling to the variable file. So providers, what are the providers, guys? AWS is the provider. Versions, we need to provide the versions for Terraform and AWS. So variables, so main.tf having all the information. So main.tf having all the information, something like EC2 instances, RDS instances, and S3 bucket, and Route 53.
ESP.
Yes, VPC, everything will be provided in the, everything will be write it in the main.tf. So in the providers, what are the providers you are using? Versions. Which version you are using, Terraform or AWS? In the variables, so whatever the variables, something like you can define the variables in here, and you can call it from the main. So this is the architecture. This is the architecture of the Terraform, guys. So main.tf, provider.tf, portions.tf, and variables.tf. Guys, now you understood? So I will show you one example.
Yeah, okay. After that, I will ask question.
Yes.
Yeah.
So these are the models, guys. S3.tf. The generic example, guys. AWS. Let me check it. Who is coming? Yeah, the same way, something like a providers.tf. So what is the providers.tf? So provider equal to AWS, something like AWS. So profile equal, it is calling as a var. So it will be checking. So what is the profile? And the region, it will be checking in the var file. So this is the provider AWS. Profile is equal to var.aws and hyphen profiler, and region equal to var.aws underscore region. So let's check it in the var file. Let's check it in the var, the variables. Yeah. So what it will be? So variable AWS underscore profile equal to description local AWS profile name type equal to string. So AWS region equal to type equal to string default equal to US East 1. So it is calling. So var that something like what is that? Providers, right? Yeah. The provider is calling a variable. The provider is calling. So where it defined in the variable.tf. Variable.tf. The same way. So here not in Terraform.tf was. So these are the Terraform.tf files. So AWS region equal to US East 1, environment equal to prod, application equal to ACM. So these are the VPCs. Something like so kapama dot something like so this is the main file he is using. So this is the main file he is using on providers subnets. So vpc.tf. So he is separating everything. He's separating everything, guys. So local dot common tags. It will be a locals. There will be in the locals. So local.tf. Right. So the Terraform.
All these TF files are created by whom? You only, or something default it will create? Yeah.
No,
The
you
document it will be available or
no. You only can create, right?
okay.
Okay. Terraform examples. I will show you guys. It's the structure they are creating. Let me show it. Usually they created a main.tf, outputs.tf, providers.tf, variables.tf, and the oceans.tf. So these are the minimum, a default files, guys. Main.tf, providers.tf, variables.tf, and the outputs.tf. Whatever you want, you can create it, guys. Whatever you want, you can create it. You understood? You see here, something like a main.tf, output.variables.tf, something like this is another stack, something like main output variable.tf. This is
What the exact purpose of this TF files means? Why we need to create this much of TF files?
Yeah, you need to separate something like, for example, a good question, guys. Good question. So something like, so if you write it in the one file, so something like, is it paint, right? Explained, but there are not written paint sorry. Yeah. So something like this is the one stack. Continue with try. So for example, this is the one stack. So this stack having only one, so one main.tf file. So everything you write it on the under main.tf file. So it is difficult to figure out. So if it is difficult to figure out, something like you need a DNS, you need a route 53, you need a S3.bucket or something like. So it is a difficult to figure out. So where it is, something like how it is. So then you can segregate it, something like versions.tf. So versions.tf, it will be available, the version stuff will be available in the versions of the AWS and Terraform. Something like providers, providers.tf. So what is the provider? So in the main only it will be a something like EC2 instance, RDSS it will be. So in the providers, you will mention in the provider something like a, so Terraform and AWS, something like versions in the Terraform. So versions in the Terraform version and AWS providers. So AWS is the provider, right? So then variables.tf. In the variables.tf, something like you need to mention some part, something like so we want to segregate the S3, etc2, and whatever it may be. The files will be whatever the something like a variable information. The variable information will be added here, and you can call it to the main. So the main TF file will simplify and we'll call it to the, so we'll call it to the other TF files. It will be simplifying and we'll add it to the other TF files. Something like you need to add the outputs. I want the outputs. So I want the output for this main. So you want to create outputs.tf. So you can mention the outputs will be added into the outputs.tf, or something like versions, providers, variables, outputs, and main. So this is the, for simplifying your code, the purpose we are segregating the files. We are segregating the files into, so different, we are segregating in different files. Versions.tf, providers.tf, and variables.tf, and outputs.tf. Now you understood?
Yes. So whenever we need that versions, providers, and variables data, then we can call it right in the main program.
Yes. So if you run so something like the main, it will be calling, if you run the Terraform plan, it will call it the main. So whatever we want, it will verify it on the, so something like a versions. It will be verified on the versions.tf. Something like providers. So which provider we need to deploy? Something like AWS is the provider. So main call it as a providers. So main call it as a outputs variables. Main call it as a outputs. So something like the stack name is something like a dev stack. For example, this is the dev stack. So this is the dev stack. Dev stack having the main, versions, providers, variables, and outputs. Okay. So I have already recorded one video, guys. I will put it in this your drive. So because of so I'm unable to add it in my my system because of this is a company system. Okay. So this is the default structure for the Terraform, guys. Main versions, providers, variables, and TF. So from now onwards, you guys can rename it for your my first EC2 instance into the main.tf. Then you can segregate the versions, providers, and variables. Okay. Understood?
Yeah, yes.
Okay. So this is a Terraform, guys. So we will continue with the Terraform also. Something like whenever we start the services, AWS services. So that time we can also so we can also build the provision the services through Terraform also manually. And please guys, mute yourself.
So you'll be marking on schedule or what do you
So Pau,
Are you talking about the books?
mute yourself.
You want the administrator, right? You can put it mute.
Yeah. I'm trying, guys. Okay. So this is nothing but a Terraform, guys. Guys, going forward, you can build our provision through the code only. Okay. You can build and provision through code. So you guys are understood, right? What is Terraform? Right? Guys,
Yes, Hari. Yes, Hari.
yes. What is Terraform? And why Terraform? So how to write the .tf files? How to write the code or something like a code? You guys are understood, right? How to write the code also. So the main thing is so registry dot terraform.io. You guys can go through this link. So if you need any example, you guys can go through this web URL. So web URL, something like a website, you will get it. Okay. The documentation, whatever the provider you're using, you can use that provider and you can go to the documentation, then you can search it on the resources. Whatever the resources you want to add. Guys, understood, right? Yes. Now new. So what we will discuss, guys? We will discuss about the, let me check. Yeah. So what we were discussed, guys, we were discussed about the cloud, AWS services, cloud providers, everything, right? So what is S3? Guys, what is S3? S3 is nothing but a simple storage service. Right? Let me go. So understanding the storage in AWS. So something like a simple storage, a solution or a service. So something like a S3. S3 is nothing but a simple storage solution. Understanding storage in AWS, different types of storages in AWS. So what is Amazon S3? Functions and concepts of S3, advantages and disadvantages of S3, a requirement for S3, understanding the pricing of S3, creating and managing S3 buckets, creating and managing objects in the S3 bucket, uploading objects to S3. So deleting the bucket, deleting the objects. So this is the agenda, guys. A storage is available in AWS. Storage is an important role AWS and find the below storages available in AWS and uses. So storage is available in AWS. Storages is an important role for an AWS and find the below storages available in AWS and uses. So Amazon S3. So Amazon S3 is the scalable storage in the cloud. So what is scalable, guys? So what is a scalable? Something like in our Linux box, something like you added a. So you added a something like so you added 2 hard disks, right, guys? So in the Linux, you added it to 2 hard disks. These are the HDD. So this is the HDD. So this is the HDD. Something like you added a 2 hard disks. One is for 10 GB, and so the other one is for 10 GB or 20 GB. You added 2 hard disks and created the partition and mount it under the. So mount it under the slash, for example, slash app logs. So you mount it under the slash app logs. So if you want to add something like the 20 GB, so the logs are occupied with the 20 GB. I want to extend this hard disk. Is it possible? No. So no, there is no possibility to extend the logs, right? So something like that, logs are filled with the 20 GB. There is no space. I want to write the logs in the app, something like app logs in the directory, but there is no space. So so if you want to add the space, definitely you need to add a hard disk. You need to add a hard disk and attach it to the something like another 30 GB hard disk you attached and add it to the app logs Now it is a 50 GB. So after 50 GB, so we need to add another hard disk. Something like if you want to scale, it will not automatically scale up. It will not automatically scale up. So they scale up the hard disk. Something like okay, scale up the volume. So in the hard disk, in something like in the Linux, definitely we need to add the hard disk and create the partition and attach it to the app logs. But in the S3 bucket, so but in the S3 bucket, it automatically added something like, for example, you created a app logs directory, app logs, something like a bucket. So you are trying to add the data into the app logs. For example, so whenever you add the data, it automatically scale up. We don't need to extend or we don't need to reduce the volumes. So it automatically extends. It automatically reduces. So something like, for example, so if you use the 2 GB, for example, here 20 GB. So for example, in here, something like app logs. So app logs. So your thought is like nothing but 6 months. For 6 months. So it will sustain. 20 GB is sustained for the 6 months. So something like that, the app logs every day who are log in, log out, whatever the actions are done. So that logs will be write it in the app logs. Something like what you are thinking is something like, for example, this is 200 GB. So 200 GB is sustained for the 6 months. So you are thinking on something like you thought is something like so 200 GB is sustained for the 6 months. But starting onwards, you created a 200 GB and attach it to the app logs. But from day 1 onwards, you need to pay the money for the 200 GB. So 200 GB. But in the S3 bucket, so something like a daily you are writing a 1 GB of daily you are writing a 1 GB of file. So first day, so the first day you write the file 1 GB. So you can pay for only 1 GB. The second day, something like you write a 2 GB file on the second day. So you can pay only for the 3 GB. Only for the 3 GB. So you can something like so here 200 GB. After 200 GB, we cannot write the logs, right? But here, so we can write the log something like a PBs of something like a terabytes and petabytes petabytes of data. It automatically extend the volume. No need to attach the other hard disk. It will automatically increase. It will automatically scale up. It automatically the scalability is there in the S3 bucket. So this is the advantage. So what is the advantage, guys? So for in the Linux environment, so you can create a 200 GB, but every day it is writing the log is 1 GB. But you created a 200 GB for 6 months. It will sustain. From day 1 onwards, you need to pay the, if you are using or not, definitely you need to pay the amount for the 200 GB. But in the S3 bucket, so what is the slogan, guys? Pay as you go. So pay as you go, something like whatever you so whenever you use that whenever you use that service, that time only you can pay, otherwise you cannot pay, something like so first day you use the 1 GB of, you write the 1 GB of file. So only charge only it will charge only 1 GB for 1 GB. So tomorrow you something like you created a 2 GB of a file only, so it will be scaling up. So it will be a scalability. S3 is the scalability service, is automatically scale up. So no need to add or no need to extend our volumes. Guys, understood? So that is nothing but a scalable. Amazon S3 is the scalable storage in the cloud. There are different types of storages, or volumes are there. The first one is Amazon S3. Amazon S3 is the scalable storage in the cloud. So Amazon Glacier. So Amazon Glacier is the low cost archive storage in the cloud. This is the low cost. So if you use the S3, so it is somewhat cost, something like it compared to Glacier, it will be a cost. Something like Amazon EBS. So EBS is nothing but elastic block volumes. Elastic block volumes, EBS, elastic block storage. So elastic block storage. So if you attach the volumes in our instance, definitely we need a EBS. So persistent block storage volumes for the Amazon EC2 virtual machines. So in the Amazon virtual EC2 instance, definitely we need to use Amazon EBS, elastic block storage, guys. Amazon EC2 instance storage. So there is a temporary block storage volume for the Amazon EC2 virtual machine. So there is a temporary storage, Amazon instance storage also there. Most of the cases we are using the Amazon EBS only. So AWS import and export. There is another storage service also, large volume data transfer for we are using large Amazon AWS import and export. Amazon storage, AWS storage gateway. So integrates on-premise IT environment with cloud storage. This is for a integrate on-premises IT. This is nothing but a data center environment with a cloud storage. So if you want a cloud storage, but your servers are in the on-premise, definitely you can use the Amazon AWS storage gateway. Amazon CloudFront. Amazon CloudFront and content delivery, global content delivery network. It is also using the storages. So something like Amazon SQS, messaging queue services. Amazon RDS. RDS means relational database. So managed relational database server for MySQL, Oracle, and Microsoft servers. Amazon DynamoDB also database. Fast, predictable, highly scalable, and NoSQL data store. So Amazon Elastic Cache also in-memory caching services. So Amazon Redshift, fast, powerful, full managed petabyte scale data warehouse services. So databases on Amazon EC2, self-managed database on Amazon EC2. These are the storage storage services. Storages are available in the AWS. So what is AWS S3? So Amazon Simple Storage Service is the storage for the internet. We can use Amazon S3 to store and retrieve any amount of data at any time from anywhere on the web. So something like a Google Drive. So this is the Google Drive, right, guys? So Google Drive also one of the storage. The same way Amazon also something like Azure. Azure also a OneDrive. The same like as a AWS also created a S3. Simple storage service. Simple storage service is the storage for the internet. It will provide the internet where your storage will provide your storage provided in the internet. So this is the Google Drive. So the storage is provided in the internet. So we can use Amazon S3 to store and retrieve any amount of data at any time from anywhere on the web. So we can accomplish these tasks using the AWS Management Console, which is a simple and intuitive web interface. Sign up for the Amazon S3. So create a bucket, add an object to the bucket, weave an object, so move an object, delete an object in the bucket. So these are the sign up for the AWS Amazon S3. You can create, once you log into the AWS, then you can go to the S3 service, create a bucket. So add an object to an bucket. So bucket. So what is object? So whatever you are adding in the bucket, if it is a file or if it is a picture or if it is a anything, so that is called it as an object. So S3 is yeah.
What is bucket? Bucket means
bucket is nothing but a storage. Bucket. So, yeah. So some
storage, right?
yes. Something like so this is the bucket, right?
Yeah.
So this is the bucket. So your water will store it under the bucket, right?
Yes.
So they call it as a bucket. So the naming convention should be different, but the actual definition for the S3 is something like it is storing the data. It is a storage, something like same like as a Google Drive is a storage. OneDrive is for storing the data, The same like as a AWS also storing the data. AWS S3 is a simple storage service. In the simple storage service, they call it as a buckets.
Okay.
So these are the buckets. So in the buckets, you can store the data. So S3 is designed for remote data store, low cost, pay as you go, no upfront cost, high availability, high bandwidth. Uses Amazon own network. So remote data storage, so low cost, pay as you go, no upfront cost, high availability, high bandwidth. What are the features? Features is nothing but 99.99% durability, 99.99% availability. So designed to support concurrent data failures in 2 physical facilities. So March 2006, Amazon launched simple storage service. So when it was launched? It was launched on to March 2006. Functions and concepts of a S3. So allows unlimited storage of the object. Object is nothing but a file or so anything is nothing but an object. So containing of a 1 byte to 50 gigabytes each. Allow unlimited storage of objects containing of a you can upload a object, you can upload a file with a 1 byte or you can upload a file with 5 gigabytes. 5 gigabytes each. So something like objects consist of a raw object data and metadata. Objects are stored and retrieved using the developer assigned key. Data are kept secured from the unauthorized access through the authentication mechanism. Objects can be made available to a public by the HTTP or a BitTorrent protocol. So all objects are stored in buckets. All objects are stored in the buckets. A bucket is simply a container for the object. A bucket is simply a container for the object. It is used to partition the namespace of the objects at the highest level. Buckets are similar to the internet domain names. They are accessed via bucket name.s3.amazon.com. So you can check it in the internet also. Each developer account has a limit of 1000 buckets. A key is the unique identifier for an object within a bucket. So how you can define a unique key? So bucket and the key together uniquely identified with each object in the S3. Every object can be addressed through the bucket and key combination. For example, if your bucket name is my bucket and the key is myhomepage.html, the URL for the object will be http mybucket.s3.amazon.amazon.com/myhome/myhomepage.url. This is your bucket. So advantages of S3 bucket: scalability, the amount of storage and bandwidth you need to scale as you like without any configuration changes needed. Availability, speed, throughput, capacity, and robustness is not affected even if you gain 1000 users overnight. Unlimited storage, you pay as you go, inexpensive and no capital outlay, great for the startups. Data is accessible from any location. Data is accessed from any location. Since it is based on the Amazon infrastructure, it is probably more reliable than other cheap data storage providers. So use cases: asset storage and CDN, data storage. They are using static sites, backup purpose, mobile storage backend, file distribution. So pricing: charges for using the S3 bucket is based on the allocation of your buckets. So the region of buckets. You are billed according to the storage, data transfer, and it out and the number of requests per month. So there is no minimum fee to use S3. You pay for only what you use. So you can view your current charges incurred almost immediately on the S3 portal. So what is a bucket? A bucket is a basic storage unit in Amazon S3. So what is a bucket, guys? A bucket is a basic storage unit in Amazon S3. It is a single level container and it is based on a key object associations. So details: subfolders are supported through specific content type, headers and substring mechanism. Upload and downloads are easy. So remaining of the folders, navigation of the complex hierarchy can be problematic. So bucket is a collection of objects, globally unique ID. So A to Z or A to Z something like max 100 buckets per user, no limit on number of objects. So per user you can create 100 buckets, but no limit on number of objects. So buckets, equivalent of the directories, single common namespace across the S3, but bucket names can be include /m gateway backups presentations. For example, this is the bucket name. So objects equivalent to the files up to 5 GB in the size. So identified by the key. So best practice on naming. So DNS compatible, FQDN, fully qualified domain name allows for the vhost and watch out for the SSL. No dots, something like objects, blob, don't care about the file formats, metadata can be added. So maximum 5 TB of an object. How to access the S3 storage? Accessible using the simple HTTP URL, something like HTTP. Yeah, so you can access via something like s3.amazon.com bucket key. So bucket key, so bucket. So use Amazon AWS Management Console, use Cloudberry Explorer. So S3 allows you to specify an access control list for every object in the database. You can set permissions for the owner, for authenticated user, for specific users, and for everybody. It's even possible to create a public URLs that expire at a given date. So it's maintain the versions of the object stored in the S3 and recover in case if the data loss. Something like it will be a version concept, v1.2, 1.3, it will be. So something goes wrong, so we can retrieve from the versions. So S3 ranges of class. S3 standard class for frequently accessed data. What is that? Standard class. So something like S3 standard, S3 standard, infrequent access, S3 standard, S3 standard, infrequent access, Amazon Glacier. So we can also set up auto policy for migrate data from one class to another class, like standard to Glacier. So because of Glacier is the cheapest one. So we'll tell you guys how we can transfer. So security in S3, access control list, bucket policy, key authentication. S3 also offer SSL encryption for the data upload and download. So to sign up the AWS, something like you can sign up the AWS. So log into the AWS S3 console, then you can click the S3. So create S3. We already we are ready to create the bucket using the AWS management console. Every object in the Amazon S3 is stored in the bucket. So before we can store the data in the Amazon S3, we must create a bucket. So you are not charged for the creating a bucket. You are charged only for storing objects in the bucket, for transferring objects in it and out for the bucket. So how to create a bucket? Guys, we'll show you tomorrow how to create a bucket. What are the objects? What are the something like what are the attributes in the S3 bucket? So something like the concept is nothing like that. S3. So S3 is something like a versioning, life cycle. So life cycle management, replication, versioning, life cycle management, replication, and static website hosting. So we can use the static website hosting also, versioning, so life cycle management, replication, and static website. So these are the concepts, right? These are the concepts we need to discuss in the S3 bucket. So what is versioning? What is life cycle management? What is replication? What is static website? So we can host our website, static website in the S3 bucket also, because of so there is no dynamic content need to store, right? So there is no dynamic content need to store. So you can host your website, static website in the S3 bucket also. So what are the attributes or object? What are the attributes, guys? Versioning, lifecycle management, replication, and static website. Static website in the S3. So tomorrow we will show it to guys. So how to create a S3 bucket? How we can add the objects into the S3 bucket? So yeah. So here, so we need to add one more point. Yeah. So objects, versioning, lifecycle management, replication, static website hosting. So these are the important topics in the S3, guys. What are those? S3. What are the important topics, guys? So guys, tell me, what are those? Objects, versioning, lifecycle management, replication, and static website. Guys, tell me, what are those? Guys, tell me what are the
Object.
what are the
Versioning, lifecycle management,
next?
replication, website hosting.
Yeah, so we will show you tomorrow. So how to create and so something like a versioning. It is the uploading objects.
Through web console, right? How to create everything.
To create everything on the web console. So after that, you guys can create S3 bucket through Terraform.
Okay.
Okay. Yeah. So we'll show it to you tomorrow, guys. How we can create the S3 buckets. It is a simple thing. So you can go to the services, search the S3 service and create a bucket. It will create. But so the permission is important, guys. The permission is important.
Okay. Hari, small doubt. Okay.
Mhm.
All these Terraform coding and web console services in the real time, they will provide tasks regarding related to this same type of task, whatever you have given after the class type of, right? In the real time.
Yes. I'm in a place where I cannot talk, but this is my opinion.
Okay.
We'll add the topic names going forward. So it will be easy to Easy to watch. Yeah, how? So I understood your concerns. From today or tomorrow onwards, so we will upload the class with the name, something like a Terraform. So today, what we discussed, we will rename the class topic. Okay. Yeah. So 1 second.